A reversible system can return to any state it previously occupied. From every state, there exists a path back to every other state. An irreversible transition means there is at least one pair of states where no return path exists. Irreversibility is not about probability being small. It is about the probability being exactly zero. That distinction determines whether recovery is unlikely or structurally impossible. An absorbing state has a transition probability of 1 to itself. Every other transition from that state has probability 0. Once the process enters an absorbing state, it remains there permanently. This is not a trap. It is a structural sink. The process has not stopped. It continues, but it will never leave. Absorption is permanent, not temporary. The transition structure near an absorbing set is asymmetric. States outside the absorbing set can transition into it, but the absorbing state cannot transition out. This asymmetry is the formal definition of irreversibility. The process has a direction. That direction points toward the absorbing set. There is no path back. Before absorption, the process carries information about where it started. Different initial conditions produce different distributions over future states. After absorption, the process is always in the same state. All paths converge. The information about the starting point is gone. This is not noise or measurement error. It is structural elimination of the initial condition. Running the process forward, you can track how the state evolves toward absorption. Running backward from the absorbed state, you cannot determine which path was taken. The absorbed state is the same regardless of the path. This asymmetry between forward and backward is what defines the arrow of time in irreversible systems. The past before absorption is structurally inaccessible from the present. Irreversibility is the formal expression of that inaccessibility. Financial ruin is the classic example of an absorbing state. Once capital reaches zero, no subsequent operation is possible. The dynamics have a permanent minimum. In biology, cell differentiation works the same way. A stem cell that has committed to a particular lineage cannot return to the uncommitted state. The transition is written into the cell's structure. These are not coincidental similarities. They share the same mathematical structure. Irreversibility means that the transition structure of the system prevents return. It is not the same as saying the outcome is unpredictable. You can predict with certainty that the process will remain absorbed. What you cannot do is undo the absorption. Measurement, information, or better forecasting cannot change this. The constraint is not epistemic. It is built into the dynamics.